So this will be a little bit of a repeat for the folks who were able to catch my What's New demonstration on the visualization and creative view session. But given that this is really tied to configurable platforms in Windchill, we wanted to highlight it in both sessions and make sure everybody got a peek at the exciting new capabilities. So just to set the stage a little bit, right? Today, platform structures creates configuration deliverables through filtering an overloaded product structure, right? So this should be something everybody's pretty well aware of, right? You start with something that you had to represent every permutation of options that you want in the product structure because it accomplishes the configuration through filtering the occurrences of objects in the product structure. That's great for choosing what goes into your bill of material, but it had a pretty big impact when you are really trying to influence how your product is assembled or how it is visualized. So if you had multiple occurrences of these skis that occur in different positions, you actually had to add them into the product structure multiple times. Same thing if you had a configurable product that had different appearances, like different colors you were going to market with. It required you adding that into the bill of material, into the product structure multiple times in order to capture, all of the different colors you want to go to market with. So that's great that we can accomplish that. However, it really represents a pretty big virtual design efficiency challenge when we get into very large configurable products where there is a lot of configuration impact on how the product is assembled. So, what that meant is that ultimately CAD designers were having to create a lot of additional copies of this information, or having to rely on a solution like Creo Options Modeler to actually do the variant generation as opposed to a PLM-driven path of doing the variant generation. So what we're excited to announce as of Windchill 12.0.2.0 is the next evolution of top-down design with platform structures in Windchill, and we're giving it the name Windchill Smart Platforms. And what we've done is started down a path of enhancing the capabilities of Windchill to intelligently build and visualize new variants without needing to go back and make either manual copies in CAD or go back into CAD to rely on generating those variants. What we've started with is tackling the problem of positioning. And in order to tackle that problem, we've created some new elements in platform structures in Windchill to help represent or analyze or generate those new product variants. So we've separated what goes into the bill of material, which will always be a BOM product structure driven thing, from how to assemble your product. And by doing that, we've decoupled the two portions of the equation and turned what was an exponential problem by trying to manage the occurrence information inside of the product structure into a linear problem by allowing a separate entity to drive how it's assembled. So what that means is, let's just take an example of a fuel tank, which I'll go through in the demonstration, trying to position it on a frame. If I have 4 different fuel tanks that can be positioned 4 different locations, and then I have a spare wheel and that has 2 different options that always needs to be placed opposite of my fuel tank at its center of gravity, then that's actually, if I try to capture that in my product structure, that's 16 occurrences of the fuel tank, because it can be each of those 4 different fuel tanks has to be assembled in 4 different positions. And then it results in an extra 32 occurrences of what should only ever be 2 spare wheels, because it has to be positioned opposite of it. So that's a compounding effect that position can play based on configurability. But if we separate position and manage it externally, that becomes much simpler, where we only ever have 4 fuel tanks and 2 occurrences of the spare wheel. So in order to do that, we've introduced a couple new things. The platform architecture will now have an entity called the positioning architecture, which allows you to describe functionally how that product gets assembled. We will also introduce new expression controls that can be assigned against the positioning architecture to control when something gets assembled to one position or another based on how you're configuring it. We've enhanced the concept of modules in platform structures to cover exposing CAD construction geometry that you authored in the CAD tool up to the windshield system to be used by the positioning architecture. And now when you generate new configurations, either via a variant specification or just configuring it inside of the PSB, we will actually have a positioning service which will use the positioning architecture to calculate the resulting positions of each of the configurable elements and display that in the visualization tab. Also open that in Creo view, or if you want to continue design work, we will persist that new location into a design context, so that way you can open it back in CAD and continue your design work. So this is kind of the beginning of a journey to make the next evolution of platform structures, which we're calling Windchill Smart Platforms, to allow Windchill to actually create and new assemblies or new variants, not just filter it down based on something that already exists. So just a couple key concepts to kind of build on and understand about this positioning architecture. The positioning architecture is ultimately made of kind of 3 elements. A configurable node, which is really the same configurable module that's inside your product structure. And in the context of a positioning architecture, it really is used to interchangeably represent any of the module variant children that would be derived from this configurable module. So in this initial release, we're really focused on use cases where a configurable module has mutually exclusive module variant children. And by defining how the configurable module is assembled, you can describe any of those children interchangeably. Once you've used a configurable node in the positioning architecture, you then use a interface to describe the relationship between 2 configurable nodes. In this case, I have a fuel tank, which will always be assembled to the frame. This interface establishes a relationship between each of these 2 configurable nodes and describes that no matter which fuel tank I use, it will always be assembled against a frame, no matter which frame I use. So if I use fuel tank A and a small frame, it's still going to be assembled against the frame, but a fuel tank B can also be assembled against a large frame. It allows us to describe that regardless of which module variant is used, we're always assembling it this consistent way. The last key concept to understand is locators, which are really important and provide context to the interface. A locator helps describe what, in terms of an actual position on that configurable node, will be used by that interface. In this case, when I assemble a fuel tank against a frame, what position on the frame does the fuel tank go? If there is only one position that the fuel tank always goes, then you can select that one conceptual position that the fuel tank will go against. If there is optionality, which derives when, do I position against one position or another, then you can select multiple locators and assign expressions to control when it gets placed on each of the positions. So the combination of these elements, the configurable node, the interface, and the locator provides a conceptual description of how any variant from a configurable structure would need to be assembled. The next concept is, how do you describe something that the positioning architecture describes in absence of a specific module variant? How do you apply that against each of the different variants that go underneath the configurable module? We do this by mapping the locators that are used in the positioning architecture against the named coordinate systems that are exposed from the CAD associated to the module variant. In this case, for design consistency, each of these module variants had a coordinate system called left mounted and a coordinate system called right mounted, but each module variant placed that coordinate system differently based on the shape or the actual CAD design. And by mapping these coordinate systems against the architecture's locator, then we know whenever we assemble a fuel tank and it uses the left mounted locator, we use the coordinate system from tank D named left mounted. But if I use tank C, it'll use a different coordinate system that has the same name but exists in a different location inside of tank C. So this mapping allows us to interchangeably swap out which component or which module variant and still derive its resulting position. And in order to expose these coordinate systems that are used by the positioning architecture, we need to expose that during the publishing process of that data, and we select what coordinate systems are of interest by providing a parameter name that has been assigned on the coordinate system in CAD and the value to filter out what they are. So in this case, all you need is a parameter on the coordinate system in Creo. And when we see that parameter on the coordinate system, we'll expose it to Windchill so that way we can use it for positioning. What this does mean is that while the dynamic positioning capabilities are CAD agnostic, and we can do this in any CAD system, the only CAD system we currently expose the coordinate systems for is for Creo Parametric. We are going to be evaluating in the short term, working with Theorem as our partner, to expose this for CATIA as well, which means the entire process would work for CATIA as well. And we'll also evaluate other means in creating these coordinate systems to map to the locators as well. All right, so let's walk through a 2-minute example of kind of conceptually how this works, and then I'll round it out with a quick demonstration. So when I'm building up this positioning architecture, we start with the configurable nodes, which is in this case a door and a lock. Now, I don't say if this is a front door for a 2-door version or a front door for a 4-door version, because I'm describing it just that the front door always has a lock. I also don't describe which type of lock it is. It may be manual, electric, or wireless, a keyless entry. I just walk next to it and it unlocks. But the architecture describes that a lock always gets assembled to the door. Now, the locator on the door will have a position that locks get assembled to on each door, and the locks will always have a position that it knows relative to the door. And the combination of those two get mated together and allow us to position the lock against the door. When we expand that out, in this use case, we have a simple car. The car, which is kind of my orientation to the root coordinate system, always starts by assembling the body. And then when I have a door, the door will get assembled to the body, and then the mirror will get assembled to the door, and the lock to the door, and then the striker to the lock. By creating this functional view of how something gets assembled, we can then apply that and interchangeably build the resulting products. In this case, I have a two-door variant of the body. My product structure expressions have chosen which door I need to use, and it's a little longer because it's only a two-door version. And my configuration rules have also decided that, I'm going to have a manual lock. And by using this positioning architecture, we can mate the door, which exists up here, to the body by using the locators that are present in this interface. In this case, here's the locator on the door side, here's the locator on the body side, and we would mate those two together and know exactly how to assemble the two. However, if I change my configuration rules and swap this out to a four-door variant, my product structure configuration rules would also swap out the front door, so that way it's shorter, but it gets positioned consistently. I don't have to have an extra occurrence. And I don't even have to change which lock I'm using. It can reposition itself because it knows how to assemble itself on the shorter version of the door. So let's take a look at what that looks like in action. I have here a product structure here, and I have 4 different fuel tank variants, each with a different configuration expression on when I would use them. And I have in my same chassis, I have a frame of which I have a long or a short frame, which the fuel tank will need to get assembled against. I now need to open and work with an architecture to incorporate that. So I can go just in the actions and say open in architecture editor. Inside of my architecture, we see here it's represented graphically, and I can either pan around and drag it around. I can zoom in and out just with my mouse scroll, or I even have a little mini map that I can see here. I can then incorporate elements into this by expanding it and using this little dragger. The dragger will only be present for elements which have not already been added into the product structure. I can drag that in here and it will get dragged to the graph. It will check out the truck because I'm now modifying it. I can establish a relationship between the fuel tank and the frame just by dragging between this little node on the outside and the node on the frame. Its initial interface will be dashed, indicating I've not fully defined it yet. I can then go in here and select which locators I want to use to position the fuel tank to the frame. In this case, I actually have 6 different positions on the frame that my fuel tank can be assembled to. Depending on if it's going on the driver or the passenger side, it also needs to be left or right mounted. I then need to tell the architecture, because I've chosen more than one locator on each side, I need to tell the architecture when to use each of them. I can right click and assign an expression, in which case I can choose, I'm going to say I need the fuel tank is going to go use the option driver front to use the driver front locator. That's pretty self-explanatory. And I can continue to go in here and assign expressions against the locators, which would formally represent expressions against occurrences that I would have had to overload inside of the product structure. I can also go and assign a little bug there. Right click and assign the expressions, and I'll continue to populate those in. And then on the child side, well, I'm going to say it's going to be left mounted if it is on the driver's side of the car. So any of these options work. And it's going to be right mounted if it's on the passenger side of the car. Great. So now I've completely described how I would assemble any fuel tank against any frame. I'll now go ahead and do the mapping on the locators here. So I go to my new locators tab on the configurable module, and I can select the coordinate systems which came from CAD. And you can do that either in the drop downs, or you notice when I select a row, I visualize it correctly. I can select that graphically as well. I'll go ahead and check that in. And now I've completed my positioning architecture, and I can swap over to my visualization, and I can go and assemble a product. Now, what it's warning me here is before I've actually filtered down to a valid product configuration, it's warning me that this product is still overloaded and cannot be resolved to a specific configuration. And it's letting me know which interfaces are still overloaded. I can go here and I can go ahead and select my options. And I'm going to go ahead, actually, in the interest of time, I'm just going to go ahead and use one that I've already configured. So I'm going to go ahead and swap this, and this is going to apply a set of options. And in real time, we're going to calculate the position of all of the individual elements. However, this is a older variant spec, so I'm going to go ahead and modify this and tie it to a fuel tank and say okay. And now that should apply that fuel tank just correctly. Oh, I'm sorry, I forgot to check in after I modified my architecture. There we go. Now we should be able to refresh and have that positioned correctly. And with that, I can go ahead and filter this down. That will apply the filter. And we see now that the fuel tank's being positioned correctly. And I can also change that out. And if I wanted to go to tank A, we'd be good to go. Now I am going to very quickly, now I want to pull this into CAD. So I'm going to generate a configuration context and say, okay. And what that's going to happen is it's going to create a configuration context with these rules. I'm going to check it in, hop on over to CAD, go to my configuration context, and I can open that in CAD. And what that will do is it will build a new CAD assembly and insert all of those configurable elements and position them based on the way we position them inside of the visualization. And that means that I will be able to open directly in Creo a fully configured truck where previously I would have needed something like Options Modeler to be able to generate all that. It's going to take a second to add everything into my workspace because it's a lot of elements. But when that's done, it'll be able to open that all the way correctly. While that's opening up, I will go ahead and take a look at some of the questions. I know we're at the top of the time and try and answer some of those. So it looks like Guido's asked, even though all the variant parts are the same coordinate system, how can the positioning of the fuel tanks be different? So it may have been a little difficult to understand there. Those are not the same coordinate systems. Each fuel tank had a different coordinate system that was named left mounted that had a different position based on each fuel tank. And as a result, although we had a consistent naming mechanism, it actually would result in subtly different positions that positions all of them. Eugenio asks, is there a relationship existing or planned with functional something in Windshield Modeler? No, not at the moment, although that is something that we recognize makes sense, and we are looking at that in the future. Can you mix and match the use of dynamic positioning with the old method of overloaded occurrences? Absolutely. So the only things that use dynamic positioning are the elements in which the architecture describes. So if you don't describe any of the elements, or the positioning architecture only describes portions of it, the other elements will still continue to be positioned as they traditionally have, and you could use occurrences to filter those down. So that was Steve's question. Dale asks if I mentioned the scenario of a component having different color options. That's something that we would like to address in the future, Dale. We're looking and have a working group around how we would capture the configuration logic impact on coloring. We expect an additional entity, although it won't be the same as positioning architecture, which allows you to describe down to surface levels, what gets recolored by rules. So that will be a new element to help describe that. Brad asks, does this mean that process plans would be generated against a configuration context? What we expect process plans would be generated is against a variant, which we would be working in order to generate a process plan against a particular variant. You could also make a process plan against a configurable product. And we would be working in the future with the NPM Link team to be able to have that dynamic positioning results take the filtering that you did against the configurable product and dynamically position the elements in the process plan as well. Tom asks, do we have to use Creo Options Modeler to support dynamic positioning? The answer is no. This does not rely on Creo Options Modeler at all. It's its own independent solver inside of Windchill. I think at this point, we'll have to take some of the other questions and follow up with them offline since we're already a little bit over at this point. Yeah, I appreciate everybody sticking in a little longer, though.
Yeah, thanks, Robbie. Thank you, Jeff, so much for presenting today, and we will gather the outstanding questions and include them in a Q&A doc. We thank you for your participation today, and if you have any follow-up questions that weren't addressed today, please feel free to email Robbie or Jeff and copy me as well. Again, thank you to the presenters. Thanks for your participation, and we'll see you on the next event. Have a great day.
Thanks, everybody.
Thank you.